Once again, thank you for Liberty, giving us this opportunity to do this lovely show for you guys at home. Now, many of you went back to school this week. I hope it was okay. I know it was weird. It was different. Unfortunately, under the circumstances, that's what we need to do. We need to practice the social distancing thing. And I believe it or not, just as weird as it's for you, it's weird for me as well, teaching with a mask and all of that. But for the ones who did go to school, well done. So we need to get this ball going. Just on a different note, I want you guys to pay attention. Obviously, the show is live. So we are being hit with a massive, massive mid-latitude cyclone as we speak. For the learners down in Cape Town, I'm guessing you're experiencing a lot of rain, winter rain at the moment. Us up here in Gauteng is going to experience very cold conditions over the next couple of days. Pay attention to it, especially once we are done with this episode of Geography. Please tune into the news channel. Go and check the weather channel. See what's going to happen in the next couple of days, because we inland might going to experience frost and below freezing conditions. And once again, you know, it's so much integrated what we've learned this year so far. Okay, so what we're going to discuss this week, we're going to have a look at last year's final paper. Now, grade 12s, there is so many formats, platforms where you can get old question papers. Now, I can't express it enough how important it is for you to get past question papers to help you with preparation for your prelim exams as well as your final exams. I can guarantee you, if you're a 70% average student and you go and work through at least 10 old question papers, I can guarantee you can make it 70% a distinction at the end of the year. Okay, very important. So what we're going to have a look at, we're going to have a look at last year's final question paper, the 2019 Theory Paper 1. Okay, but let's just get sucked into it. Please, if you can, try and download the paper, try and print the paper, and we can work through it together for the next 3 to 4 weeks. Okay, but we need to, and as I go through the questions, I'll obviously explain it with diagrams, etc. But let's get into it. So our first question, if we have a look at it, our questions always start with short-based questions. Now this is a short-based question. 1.1. Give one term for each of the following descriptions by choosing a term from the list below. Now, I'm just going to have a look at the terms that's being mentioned over here. I'm not going to circle them. I'm just going to circle this whole block. They mentioned radiation fog. They mentioned katabatic, temperature inversion, anabatic, smog. Well, the smog is a mixture of pollution and fog, but we'll get to that. There's thermal belt, frost, and aspect. Now, grade 12s, immediately, if we just look at the terms that's being presented to us, I know for a fact we're discussing the local climate. And we can go even a little bit further, we're discussing valley climate. Now, before we're going to answer the questions, I'm just going to draw a diagram, and I'm going to explain to you question 1.1.1 all the way to 1.1.7 in the diagram. I'm just going to draw the diagrams. There's actually two that I'm going to draw. Okay, so let's have a look quickly. So like I've mentioned, we're discussing valley climates. First of all, we experience two different types of valley climates. Okay, one during the day, that's my valley. One during the day, I'm just going to make a little sun over here. And it's usually where air rising parallel with the slopes. Okay, because it's hot, air rises, what we refer to as anabatic breezes. Okay. And during night time, we experience also a breeze, but just a little bit different. Okay. So during night time, I can't use blue because the blue is the background, but at night time, what happens with the air? It sinks to the bottom of the valley. What do we call this? It's known as katabatic breeze. Okay. More importantly, when we experience this breeze during winter, you need to keep in mind So the surrounding area, as the cold air drains to the bottom, it's much heavier, it's denser. So it sinks to the bottom of the valley. It collects on the bottom of the valley. So as you can see, what do we experience over here? We experience convergence of cold air. Okay, it's convergence of cold air. Now, what have we noticed? Keep in mind, cold air is heavier than warm air. So it's much more dense, it's heavier. So what's it going to do with the warm air that was inside the valley? So if we go back to our diagram, what's going to happen with the air that was inside? This cold air is going to force this warm air upwards. Okay. It's going to displace this warm air. So I want to go back to my example. Think about it. You jump into a swimming pool. Where do you find the coldest water? On the bottom of the swimming pool. The warmest water usually on the top, right? Same here. Now this is in the valley. The surrounding areas, it cools down. The air sinks to the bottom of the valley. It collects on the bottom of the valley. Displaces the warm air. When this displacement takes place, it's known as the thermal belt. Okay, but more importantly, grade 12s, what basically happened over here, inversion has been created. Okay, right here, inversion was created. Now, once again, what's an inversion? First time introduced to it in grade 10 when we look at the structure of the atmosphere. Inversion is when we have an increase of temperature with altitude. It's not normal. It's like saying you go and climb Mount Everest, and how higher you go with altitude, how warmer it gets. It's not normal. What's supposed to happen with the temperature? It's supposed to decrease. Now, going back to my diagram, look what's happening over here. We go from cold to warm. It's not correct because we're going up with altitude. Am I correct? So that movement, what we experience over here is inversion because it's supposed to, but over here we have a normal lapse rate because we're going from warm to cold. Why does it get cold up here again? Because of terrestrial radiation. Remember, the surface loses its heat, especially during winter times. Okay, now, what's important in this diagram? First of all, this is the thermal belt. We as humans usually tends to, before I continue, first of all, we as humans tends to live on the warmest slopes. If we look at this valley, right, over here, remember aspect, actually discuss it with my learners today. Remember, if we walk into that direction to the equator, which slopes are going to be warmest? The north-facing slopes. The south-facing slopes are going to be casted in a shadow. Why does north-facing slopes warmer? Why is the north-facing slopes warmer in the southern hemisphere? Because they face towards the equator, as you can see it. They receive direct insolation. Okay. And as you can see, our south-facing slopes is casted in a shadow zone. They don't get much insulation. So if you had to go and build yourself a house inside this valley, first of all, you're going to try and build your house on the north-facing slope, assuming that we're walking into that direction to the equator. Okay, so you're going to build your house over there. If there's no more space to build your house in the north-facing slope, where are you going to build your house? You're going to build your house in the on the south-facing slope, inside the thermal belt. Very importantly, because remember, the warm air is being displaced, so you will experience warmer conditions once you're in that thermal belt. Now, definitely a big no-no is to go and settle, have a look here on the bottom of the valley. Because what are we going to experience over there? A frost pocket. Okay, why? Because especially now, we're talking what basically happens in the next couple of days. We experience an intense cold front. So we're going to experience a steep drop in temperatures. I can guarantee you, in valleys, in the interior, we might experience definitely, in our diagram, we're going to experience frost because the temperature is going to drop to extreme temperatures. So we're going to experience a frost pocket. Now, first of all, we don't want to go and live there. But if we do live there, keep in mind, farmers tend to move to the bottom of the valley. Why? Because it's a flat gradient. Now, what's important over there is they need to plant frost-resistant crops. Okay, very important. Now, I just want to clear my diagram a little bit, and I want to explain what happens when we have urban settlements. Now, like I've mentioned to you, many settlements settle in the bottom of the valley. So I'm going to draw houses and buildings. Okay. The reason why they settle in the bottom of the valley is because of the gentle gradients. Now, what all settlements do, it's where people live. What do? We create pollution. Okay. How do we create pollution? Driving our cars, manufacturing, burning fossil fuels. Okay. But what happens when we have a settlement in the bottom of the valley? It creates pollution, and down in the bottom of the valley, it creates smog. Now, what is smog? Smog is a mixture of pollution and fog. And the problem with this smog, it gets trapped below the thermal belt because it can't rise. Okay, because we got warm air above it. Now, this is basically your normal valley climates during the winter. Okay, so we looked at it during the day, anabatic, during the night, katabatic. Okay, but then it collects in the bottom, we experience a frost pocket, and we experience a thermal belt. Now, let's just quickly go and have a look at the questions, what's being asked. They just asked us the terms of it. Okay, so the first question is the zone where a warm air mass is trapped between two colder air masses. Let's go back to our diagram. There's cold air. What did we say is over here? Cold air. What did we call this warm air mass? You're correct. It's a thermal belt. So the correct answer over there, I'm just going to erase it for 1.1.1, is thermal belt. Okay. I hope you pay attention. Do you know how cool it will be if you can have this same question paper in front of you? So just try to have this question paper next week in front of you while revise it. It's going to be excellent. Okay. Now, if you look at question 1.1.2, a mixture of smog and fog, I've already mentioned it to you. It's known as smog. So I'm just going to delete that term over there. Okay. The direction in which the slope faces in relation to the sun rays. I've mentioned it to you before. A couple of minutes ago, I showed you a diagram. It's our north and south facing slopes. Our north facing slopes are warmer in the southern hemisphere because of direct insolation. It's going to be vice versa. Keep in mind, the examiner will always try to catch you out. Okay. What's going to happen if it's in the northern hemisphere? Which slopes are going to be warmer? The south-facing slopes, because they're facing towards the equator. And what do we call all of this? It's known as aspect. Okay. So let's go back to our terms. Do we see the term aspect? Yes. So 1.1.3, the direction in which the slope faces in relation to the sun rays is going to be aspect. Okay. Now 1.1.4 forms when calm conditions and clear skies occurs in the valley. Okay. Now this happens, calm conditions and clear skies. It's usually in winter. Okay. Because we have clear skies, right? And the correct term for that will be radiation fog. Now, if we quickly look at 1.1.5, forms on the valley floor when the air temperature is below freezing point. I've mentioned to you before, especially happens during winter. As the cold air subsides, it collects, right? And there's a correct answer. It's known as the frost pocket that we may see. It might happen, definitely happen in the next couple of days with the extreme cold front, mid-latitude cyclone taking place. 1.1.6, if we look at 1.1.6, the type of wind that results from air sinking down the valley slope at night. So there's two tips. The air is sinking and it happens during night. And we've mentioned katabatic breezes. Okay, so we can remove a katabatic breeze. If you look at question 1.1.7, type of wind that results from air moving up the valley slope during the day. Now, any time that wind will move upwards is usually when there's warm conditions. So when do we experience warm conditions? During night or during the day? Obviously, we discuss it. There's our first image. If you look at it, anabatic breeze. So the correct answer is anabatic. And obviously, the term temperature inversion didn't match any of these concepts. And that, great Charles, that's how easy it actually was. Okay.